Okay, lovely. Thank you, David. And
no worries.
Thanks for all the previous presenters. You just give me huge pressure on to make this one at least as good or as slightly lower is fine. So I appreciate Carrie's comment in terms of patience. Yes, to put together an institute to take a long time. So for me, it's an interesting discovery and journey as well. But we have this UTS Data Science Institute. Interesting is the timeline is right before COVID. So, and then we happen to have a lot of gatherings together, and even seminars, workshops, all those fancy stuff. We haven't been able to do much. However, the work continues on. So who we are. I mean, usually I put a one page of a blurb of UTS. For the reason is UTS has a very good disciplines in others. For example, nursing is pretty good. Design is pretty good. Oh, sorry, I just couldn't even bring the things onto my mind. Sorry, we have so many fancy, fantastic faculties, but the one I really wanted to focus on is the Faculty of Engineering and information. So in this faculty, actually two or three, we say pillars. One is, of course, a broad range of AI data science, or coming from computer science, so all based on the computer science, the school. So has been consistently ranking good and also progress really, really well. I think the trajectory, probably as a 40-year-old university, is really something we should be proud of. And then the other ones, the robotics is quite good as well. And then we have a biomedical or civil engineering, transport, all those ones. So the fantastic thing for us is working cross-disciplinary quite closely. And I will give some examples and then later on. So from the Data Science Institute perspective is luckily we put together a critical mass. So I mean, depends on the contract expiring time. I would say roughly it's like a 40-ish full-time employee, academics, and then there's a 40 some others or 30 others, which is we have a large amount of software engineering engineers, for example, for various different industry sponsored projects. And we have various different associate members coming from various different faculties, including law and social sciences, and of course science, and then other like civil engineering, material science, you know, biomedical, all those, you name it. And we have a large amount of PhD students working with us. That's also a really luxury thing. So focus, of course, around, you know, people using very different words. So I like machine learning, so just stick with that. So we have AR, we can talk about data science. In the past, I can say pattern recognition, even signal processing, has lots of different words, but I stick with this one for the moment. And then we also have quite some, you know, how to say, end-to-end modules or process built in that one. For example, I mentioned software engineering, data engineering, visualization, cloud deployment, etc. Because we have large amount of industry engagement, and probably it's necessity to deliver. Actually, we deliver softwares and then even maintain the software in the cloud stuff. So proud to, we have 2018-2019 Eureka Prize from our institute. Of course, the professors are sitting in. And then we have some wonderful young researchers, which are as highly cited as they can be. I think Amir Gondami he's only 5 years off PhD, but ranked the 39 something computer science in Australia, which is, I mean, the trajectory is really amazing. So, and then, of course, publication probably is a standard KPI. I want to talk about that, but we have large amount of industry engagement and the government as well. So I'm going to talk, before that, fantastic buildings. If you're looking at the building, with the glass is actually our building. And we moved in right before COVID. Everything is fantastic, apart from I don't have a bookshelf or all those things, my books or on the floor and the papers. So it is what it is. So we have a wonderful data arena. It's not belongs to us, but we work closely, use a lot of the facility, which is the 360-degree visualization studio. And yeah, we run, I just finished a very long session with industry partners on the collaborative workshops and stuff. We also, right-hand side, we have our own lab, which is sitting in the same building as one level down, have all these fancy gear. If you look at the top one is the one we can hook up people for a long time. It's called a motorized cockpit, which is a game machine. However, we're using that to study human behavior. So it's the only 2 machines in this country is actually sitting downstairs of my office. And we have all those VR corner, etc. Okay, important what we do. I love Scott that you know, section of the diagram. I haven't put the measurement there, but we sort of like taking fundamental science and translation practical problem. This is actually one of the big areas we actually passionate about, which is how to solve the problem. And of course, those in solving that problem brings us practical research challenges. I'm going to talk a little bit in that one, in one of the case studies. And eventually, of course, developed through the partnership, collaborations, etc. So because of it's a large quantity of people have done fantastic job over years. So if you look at the chart, it's very, very busy chart, but on left-hand side, more or less like application areas, we touched upon all of them and have quite some good outcomes as well. If you're looking at the middle one, deliver these data-driven solutions for industry, sorry, should be government or partners as well. And you see the more bottom ones are more our focus, machine learning optimization, business translation with multidisciplinary science, and of course with ethical and human-centered AI or machine learning data science. And on the top part is more like the supporting component, like a visualization cloud, big data platform, software, data engineering stuff. It's as a necessity when it's required. So otherwise, we would love to focus on the bottom rather than the top. Yeah, we all know the reason. So to talk very quickly, go through some of the examples, for example, in transport. We've done quite a lot of work in terms of a network analysis of understand the people flow versus the vehicle versus trains, ferry, buses, the multimodal different connections, understand congestion, understand infrastructure maintenance, understand parking, understand incident, how you deal with, for example. In ethics and then around trust in the people, I think is that mention ethical risk in utilizing data driven solution probably is one of the very, very hot topic on that one. And personally, I'm sitting on the New South Wales Government AI Advisory Board. One of the big tasks for us, the committee is, our board is to come up with a assurance framework for government procurement or usage of the AI. I think that's a topic for another day. So in finance, automated data-driven quality assurance system for underwriting. So compare the human underwriting versus the automatic underwriting, and that have achieved quite a good result and has been actually in use, deployed for a number of years. Water is a big sector. I have one slide there. I will talk later. And health, for example, predicting the the drug side effects, optimal medical imaging, illness identification, and linked to biomedical and devices, different, treatment, lots of stuff. And then, yeah, government, of course, all of us, I think, are somehow linked to various different government departments. So show and tell, I guess the key thing is probably the industry recognition. We are really, really proud to have a whole bunch of them in transport, say like ITS Australia 2014, 15, 17 awards number of times, Eureka I mentioned. And then insurance have the innovation insurance awards, etc. I think all those is just really acknowledgement, and then how could I say, it's the thing we enjoy a lot working with our partners, because all the those industry recognition submission is jointly with our partners. So it's a wonderful outcome we actually always celebrating. So let me walk through one case which is around water. So water is a big area, and probably people asking, what sort of segment you looking into and using data science. Okay, let's walk from left to right. So from left is the problem coming from is if we're looking at the fundamental science. Fundamental science is the problem statement is, of course, you have a huge amount of data, you have a very much different variabilities in the assets, in soil, in weather, in human behavior, and how you're going to provide a certain predictive outcomes to guide government agencies or utilities to actually maintain our water assets and then also save our precious water. And then the key research we dipped into, for example, Bayesian non-parametric in terms of clustering the high demand spaces, and non-homogeneous stochastic process for modeling spatial temporal example. And business problem or domain, we have looked into holistically in terms of the asset failure, leakage, water demand, network optimization in terms of the energy consumption in sewer network, how to predict the corrosion, how to provide the best chemical dosing methodology and the tools. Actually, our tools has been deployed into water utilities, give them instant feedback of the dosing level, for example. And we worked with more than 30 utilities globally, majority of them in this country, and also a lot in UK, Netherlands, Hong Kong, etc. So in water space, we published more than 60 papers, including like ICML, AAAI, etc. And from impact perspective has been estimated by Deloitte's Access Economy of 2.6 billion something. It's a great number. I don't know what exactly how to come up with. I can dig out the report, but this is one of the reason we win Eureka 2018 and other industry recognition. So this is my last slides. Another example on the predictive asset management. When we're looking at the assets overall, you can look into the roads and bridges, telecommunication, mobile, batteries, engines, etc. But really the challenges for us is, or for everyone, is when we know we wanted to be predictive. However, we know the data itself may not be ideal. So we have imbalanced data, we have a various quality problem, we have the data coming from different legacy system is inconsistent. And also sometimes we said it's a big data, but in reality it's small data. Take example on the Sydney Harbour Bridge is there's never have a real catastrophic failure, which is good, but we don't have ground truth to depend on. And then even though we installed more than 3,000 sensors onto the bridge and collected 24/7, huge amount of data, those data is about, you know, movement and training, but really how you're going to do the predictive maintenance. That's a huge challenge. And also I mentioned earlier, in terms of spatial temporal different attributes into the potentials of these risks. And what else? Anomaly detection across all of them, but whether anomaly detection is a solved problem, I would say no. But anyway, I'm going to cut off here. I found is a huge amount of demand from government industry on data science and or machine learning, AI, whatever buzzword we use, and how we work collectively, effectively to, you know, back each other up and then, you know, make a bigger progress. I guess that's why we're here, and I'm happy to stop here. Thank you.